And yes, guys, welcome back to the channel.
Yep, this is our Chem 2C class together. Chapter 11. We're still on galvanic cells, but this time instead of doing a regular galvanic cell like in the last video, something like this, we're doing a little something different, you feel me? Um this time the galvanic cell is going to be different. So this was the last galvanic cell. I'm going to use zinc again on this side, so zinc electrode in here. Remember, electrode is the metal solid part of the electron. And I'm going to label this the anode. And this is the cathode. And, it's in zinc cations, zinc solution. Hold up, that looks like a T. Right here. And then over here, instead of copper, actually, let's still have copper. Copper, 2+. One thing about galvanic cells that to know is that this electrode right here doesn't necessarily have to be copper. Or let me use a different one instead of copper. Let me use iron instead. So over here, there's two aqueous solutions. Is that possible? Yes, it's very, very possible. And instead of the electrode being Fe solid, it could be anything. But usually in this class, the electrode that's the non-metal, you're gonna notice a pattern about how this is zinc cation, this is zinc solid. The other one was copper cation and then copper solid. But over here for the iron one, something like iron, or it could be also tin as well, where you have like Sn2+ and Sn4+. Like different cations with different oxidation states. You have usually it's platinum. There are also other things you can use, but this right here is called an inert electrode. Inert electrode, which means like how in this previous, sorry I keep scrolling up, but in this previous one, the electron comes in and goes into solutions and then goes into the cation and it becomes solid. So it goes from Cu2+ to Cu. In here, this cathode, the electron comes in, E goes in like that, and it comes in here, and the electron goes into this Fe3+ first, and then this Fe3+ then bounces up, hits the platinum, and then it becomes this as it gains the electron. So the electron goes to the platinum. So the electron is in like this thing right here, the platinum electrode. And then as the electron comes in, the F3+ bounces on the electrode, and then it creates this one. So the charge reduces. So I'm gonna write it down here. The Fe3+ in the solution meets with the electron. And then, remember, the charge is reduced. 3+ - 1. Electrons have a charge of -1. 3+ - 1 is 2. So that's why you end up with +2 instead, or 2+. And that is how you can get a galvanic cell without a metal electrode. And then in the next video, I'm going to talk about shorthand notations and how you can write it without a metal electrode. But it's basically the same thing. And then instead of like in the previous one, again, copper was created as the electron comes in here and meets with the solution, then copper is created. In this one, platinum isn't created. The electron just interacts with Fe3+, then it bounces up and Fe2+ is created instead of a solid. And that's galvanic cells without electrodes. All right, guys. See you guys in the next video.
See you in the next video.